In this video, we are going to work on verifying a trigonometric identity. And so what that means is we're basically going to prove that two trig expressions are equal to one another. And to do that, we're going to begin with an expression on one side, and we're going to use, in the second step, algebra and trig properties, so our trig identities, to manipulate the expression until it is identical to the other side of the identity. So let's go ahead and look at two examples. This first one says that secant squared of theta minus 1 over secant squared of theta is equal to sine squared of theta. So I want to start with the left-hand side. So I have secant squared of theta minus 1 over secant squared of theta. And I want to somehow get that this is equal to sine squared of theta. And so to start off with, I want to go ahead and break apart this fraction. I see they both have the denominator of secant squared of theta, so I can rewrite this to be secant squared of theta over secant squared of theta minus 1 over secant squared of theta. So you can see those are both equal. And the reason why I did this is so I can see that secant squared of theta can actually cancel out. And so secant squared of theta divided by secant squared of theta, I just get 1 minus, well, I know that 1 over secant squared of theta is the same thing as 1 over secant of theta squared. And I did this because that is one of our trig identities. And we know that from our reciprocal rules that 1 over secant of theta is equal to cosine of theta. So I get 1 minus cosine squared of theta. Well, if we go back up to our identities, I think we already have this solved from an early problem. We see that 1 minus cosine squared of theta is equal to sine squared of theta. And that is exactly what we were trying to prove. Okay, let's look at another one. So here I have secant of x plus tangent of x is equal to cosine of x over 1 minus sine of x. So I'm going to start with the left-hand side. And I want to somehow get cosine of x over 1 minus sine of x. So first I can see that secant of x is the same thing as 1 over cosine of x. So I'm going to go ahead and replace that. I want to somehow get this to be into the same fraction because I see on my final here I have cosine of x over 1 minus sine of x. Well, I know that tangent of x is the same thing as sine of x over cosine of x, so I want to go ahead and replace that. And now I see that they have the same denominator, and so since they have the same denominator, I can go ahead and add the numerators. And so I have 1 plus sine of x over cosine of x. So now somehow I need to get 1 minus sine of x into the denominator. And so one way you can do that is to go ahead and actually multiply top and bottom by 1 minus sine of x. Now I'm allowed to do that because I'm doing it to the top and to the bottom. And so when I do that, I have 1 plus sine of x times 1 minus sine of x over cosine of x, 1 minus sine of x. And now I'm going to go ahead and distribute here. So I have 1 times 1, I get 1. 1 times negative sine of x, I get negative sine of x. Inside, I get plus sine of x. And then minus sine squared of x. And I see that my middle terms cancel out, so I end up with just 1 minus sine squared of x over cosine of x, 1 minus sine of x. So I'm getting closer. I have that 1 minus sine of x in the denominator. I need to somehow get rid of that cosine of x, though, and have cosine of x on top. Well, looking at the top, I have 1 minus sine squared of x. And I know from my Pythagorean identity that that's actually going to be equal to cosine squared of theta. So I have cosine squared of x over cosine of x, 1 minus sine of x. And then I see that my cosines here actually cancel. And so I cancel this one, I cancel just one of mine up on top, and so I end up with my identity of cosine of x over 1 minus sine of x. And I see that that matches what I was trying to prove.